My name is Miles Oyer, and this is my video project number 2 for Math 1044. So for this video project, I was given the function f of x is equal to x cubed minus 3x squared plus 2x all over 2 raised to the x minus 20. I was asked to find and classify all relative extrema for f of x everywhere the function is defined. As stated above, the function is defined everywhere except at the input x is equal to 4.322. So to solve this, we need to use the quotient rule, which is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. To start solving this, we need to take the original function and find the derivative of it, which is 3x squared minus 6x plus 2 times 2 raised to the x minus 20 minus x cubed minus 3x squared plus 2x times ln of 2 raised to the x, all over 2 raised to the x minus 20 squared. Now we're going to set that equal to 0, plug it into solver. So you have your derivative that's equal to 0, and you are going to find your critical numbers, which is 1.59 and 0.428, which I rounded to 0.43. You're able to check this by graphing the function, and it shows you that your critical numbers are correct. Now you're going to plug this into the f prime sign chart, and you need to find a value on each side of your critical numbers. So I chose f prime of -1, the answer was negative, so you put a minus. F prime of 1, the answer was positive, so you put a plus, and f prime of 2, the answer was negative, so you put a minus. This gives us that x that's equal to 1.59 is our relative maximum, and x that's equal to 0.43 is our relative minimum. Now, part B is find and classify the absolute extrema on the interval -5 to 1. So to start, we're going to take our derivative, set it equal to 0, and we have our critical numbers here. We do not use the critical number x is equal to 1.59 because it is not within the interval of -5 to 1. Now we're going to put it into this chart here, which has our derivative function and the -5 and the 1 from the interval and the critical number that falls in between. So we're going to plug these numbers into our function, and the answer for -5 is -5.3470. For 0.43, it's 0.0003, and 1, it's 0.5555. So our absolute minimum is the smallest number, which is -5.3470, and the absolute max is 0.5 repeating.